Welcome to this technical explainer. Let's just jump right into it. For a long time now, we've basically treated AI models as these standalone magic boxes, right? But moving AI into true enterprise production requires a massive mindset shift. We have to start treating it as robust, deterministic infrastructure. Today, we're going to look at a literal blueprint for building exactly that. We are moving way beyond basic vector search to explore why production AI absolutely needs hybrid RAG.
Here is the architectural blueprint we'll be following today. 1. The semantic similarity illusion. 2. The retrieval triad. 3. The hybrid RAG paradigm. 4. Agent core plus harness. And finally, 5. AI transactions and governance. Let's dive in.
Chapter 1. The semantic similarity illusion.
So we've all been told that vector search solves the data problem for LLMs, right? Well, here is the harsh reality. Similarity absolutely does not mean correctness. Imagine a high-dimensional vector space. A user asks a critical question: which desserts are safe for a peanut allergy? In a standard vector-only system, that query maps right next to data chunks for classic peanut butter cookies. Why? Because they share topical relevance. It triggers a high similarity match, say 0.91, but it's a completely dangerous hierarchy. It erases exact identifiers and just creates this illusion of accuracy. The result is a system that confidently hallucinates a genuinely dangerous recommendation.
And this isn't just theory. Look at this research from BlackRock and NVIDIA. It totally nails the enterprise reality. When you're dealing with complex stuff, like annual statements or earnings call transcripts, relying solely on vectors means the model loses critical contextual information. Standard paragraph-level chunking kind of assumes all text is just uniform, but real-world enterprise data? No way. It's packed with domain-specific language and crazy multi-hop relationships. If you just rely on vectors here, you are basically asking for inaccurate predictions and completely overlooked insights.
Which brings us to Chapter 2, the Retrieval Triad.
Okay, so how do we fix this semantic illusion? We need to look beyond basic vectors and define the other tools in our toolkit. Take a look at how semantic similarity fetches data on the left. A query for euro in Paris might grab a document saying France uses the euro, just because it's nearby in the vector space, missing the exact target. But now look at BM25 retrieval on the right. This forces a strict, deterministic filter based on exact compound terms. It explicitly builds a query for Paris or euro and hunts down exact key-value index matches. It is incredibly predictable.
And BM25 isn't just about simple keywords. It's a highly predictable ranking algorithm that scores documents based on exact string token matches and how frequently they appear. Plus, you can compound it with hard metadata filters. Imagine you strictly lock the search to the topic of geography. When a user asks, "What is the capital of Australia?" BM25 immediately filters the lexical index for the tokens capital and Australia while enforcing that geography tag. Boom, you get precise, deterministic, top K retrieved context chunks every time.
But what happens when you have really complex relationships? That is where knowledge graphs come in. They use named entity recognition to map data out into a structured, dynamic web of explicit multi-hop relationships. Instead of treating text like a big, messy blob, it breaks it down into specific nodes, entities like person, location, organization, or date. So Barack Obama is a person, and he's linked explicitly by directional arrows to the United States, a location, during a specific date range. It strictly views documents as a collection of triplets: subject, predicate, and object.
Now, let's put these three side by side. No single tool is a magic fix on its own. Standard vector embeddings? Great for casting a wide net and catching nuanced concepts, but they come with a high hallucination risk. BM25? It guarantees deterministic keyword matching, which is awesome, but it has literally zero semantic concept awareness. And knowledge graphs? They are the absolute gold standard for factual faithfulness, offering insanely high accuracy by mapping out explicit relationships. But yeah, they do require massive effort and complex ontologies to actually build.
All right, Chapter 3, the hybrid RAG paradigm.
Because of those pros and cons we just covered, enterprise production absolutely demands a two-phase hybrid RAG framework. Think of it like a layered blueprint. Phase 1 is the truth grounding phase, the solid green foundation. This is where we use our deterministic retrieval, so our knowledge graphs and BM25 metadata filters, to strictly lock down verified facts and strike out unsafe variables right at the root. Then, Phase 2 is semantic nuance. Once the facts are securely locked in, we pour this fluid, cool blue semantic text over that green foundation. This vector layer blends in to give the final output a natural, human-like conversational flow.
By physically moving data through both of these pipelines, hybrid RAG acts as the ultimate failsafe. On one side, we have traditional vector database creation, breaking PDFs into chunks, making embeddings. On the other side, we've got the graph retrieval architecture pulling out entities and relationships. So VectorRAG completely misses the exact context for an extractive question, the system just falls back to the graph context. And if GraphRAG comes up empty on some highly abstract question, it falls back to the vector context. They literally cover each other's blind spots.
And honestly, the results of this combination are staggering. In tests on massive datasets, like the complex Nifty 50 earnings call transcripts, hybrid RAG dramatically outperforms standalone methods in both faithfulness and context relevancy. Now, full transparency, there is a minor trade-off. Because you're taking graph context and appending it to vector context, the total chunk gets bigger. That can slightly lower pure context precision just because there's extra information in there. But trust me, it is the ultimate necessary trade-off if you want accurate, grounded answers in high-stakes financial or enterprise environments.
Chapter 4, Agent Core plus Harness. Okay, pivot with me here because I want to talk about the actual execution environment. Prepare yourself for a bit of a data shock. Up to 98.4% of an advanced production agent's codebase is actually harness infrastructure, not the AI model itself. 98.4%. Think of it like a massive, rugged exoskeleton cage that docks and locks completely around the LLM core. That exoskeleton is where the vast majority of your engineering effort actually goes. By contrast, that leaves a tiny 1.6% decision logic ratio for the AI model itself. Crazy, right? But this proves a huge point. In production, true AI agents are not just a standalone model. They are the model plus the harness. We absolutely cannot just let models run wild. We can only trust the model's judgment within a rich, strictly deterministic set of rules created by that execution harness.
So what does this 98.4% harness actually do? Well, it handles all the heavy lifting before the model generates a single word. It manages context pressure with compaction pipelines and budget reduction tools. It manages robust system prompts, MCC tool calls, and strict ML-based classifiers. It's doing things like enforcing linguistic negation rules, making sure it filters out that dangerous peanut allergen we talked about earlier, ensuring absolute safety before it ever hands the context over to the model core.
Which leads us nicely into Chapter 5, the AI transaction and governance.
Let's bring this all together and trace the chronological path of a single prompt on a clean enterprise dashboard. It creates a perfectly auditable flow. Step 1, user input arrives. Step 2, it hits a strict safety and permission deny first filter. Step 3, it goes through hybrid RAG verification, pinging both our vector space and our knowledge graph for truth grounding. Step 4, context assembly, where the prompt is successfully built based on those factual retrievals. And finally, Step 5, it's routed to the model for the final output. Every single step along this lineage graph is tracked, auditable, and totally controlled.
And maintaining this structured lineage relies on strict isolation boundaries. We are not talking about some fragile prototype environment where a bad prompt crashes the whole app. Production requires real recovery mechanisms, OS-level containers like Docker, version control rollbacks using Git so you can reverse any bad change, and classifier-mediated automation for safe tool execution. You are building multiple, robust layers of safety rather than just hoping a single boundary holds up.
So why go through all this trouble to build out this massive infrastructure? Well, look at this performance metric. Recent empirical benchmarking shows that if you hold the actual AI-based model fixed, but you change only the surrounding operational harness, that single model's score on long-horizon tasks shifts by up to 18 points. 18 points! Let that sink in for a second. Investing in your deterministic infrastructure, your safety layers, and your context management is vastly more important and gives you way greater reliability gains than just swapping in the newest base model.
Which leaves us with a pretty provocative final thought. As frontier models from all the big providers are rapidly converging in their base capabilities, the model itself is no longer your competitive edge. The quality of your surrounding operational harness is. So, I have to ask you, is your infrastructure ready to be your main differentiator? Are you ready to build the ultimate hybrid RAG system? Thank you so much for joining me for this explainer today. Keep building, keep learning, and I will catch you in the next one.